Okay, so in a circle, so arcs and chords, in a circle or in congruent circle, two minor arcs are congruent if and only if their corresponding chords are congruent. So the minor arcs are congruent if and only if their corresponding chords are congruent. So what's that saying over here in the diagram? So we have minor arc. We have minor arc AB. We have minor arc CD. So we can say that arc AB is congruent to arc CD if AB is congruent to CD. So if those two chords are equal, then the two arcs would have to be equal to each other as well. So if I tell you that AB and CD are congruent to each other, the chords, and if I tell you arc AB is, 60 degrees, arc CD would also be 60. Okay.
Wait, say that again?
If I tell you AB and CD, the chords are equal to each other. If I tell you arc AB is 60 degrees, arc CD would have to be 60. Okay.
Are the ones over AB and CD on the second time straight lines?
Straight lines, yeah. Straight lines over the second time to indicate segments. Then we have inscribed. Inscribed is when all the vertices of a polygon lie directly on a circle. So over here, this is an example of an inscribed polygon. Because if we take a look, the four vertices, A, B, C, and D, all lie directly on the circle. So we would say polygon ABCD is inscribed in circle E. So I would say ABCD is inscribed in circle E. Circumscribed is talking about the circle that's outside of the polygon. So if you see circumscribed, that's talking about the circle containing all the vertices. So it's still referring to the same diagram, it's just talking about the circle, not the polygon. So circumscribed would be saying circle E is circumscribed about ABCD.
So, inscribed is when
Is the polygon on the inside.
First, and circumscribed is the circle.
It's talking about the circle outside of the polygon. Yep. Still, I mean, they're talking about the same figure. It's just whether you're talking about the polygon or the circle. Okay. And then we've got this other theorem down here. In a circle, if a diameter or a radius is perpendicular to a chord, then it bisects the chord and its arc. So here, in a circle, if the diameter or a radius is perpendicular to a chord. So here, if DB is perpendicular to AC. Okay? So if this is perpendicular, it bisects the chord. So what does it mean to bisect? Cuts it in half. So those two segments are equal to each other. And not only that, the two arcs that it also cuts in half are also equal. So arc AD and arc DC would also be congruent.
So arc A, B, and BC wouldn't be?
Yep, those also would be.
Okay.
You could also view it that way. So arc AB and BC would also be.
Dang.
Is that okay? In a circle or in congruent circles, two chords are congruent if and only if they are equidistant from each other. So in a circle or in a congruent circle, two chords are congruent if and only if they are equidistant from the center. So what that means is here I have this chord AC. Here I'm going to put my center of my triangle right there, or my circle right there. Triangle. If I draw another chord, now I'll call this one XY. If these two distances are equal to each other, then the two chords are congruent. Okay? So if they're both the same distance away from the center, so if that distance is the same as that one, then the two chords are, then XY and AC would be equal. So that's the information we're going to use to help us solve. So in summary,
can you use the same formula for everything? Like when we're solving, like the first one on Monday?
so for circumference, that formula, yeah, well, that formula stays the same. So for a summary of these theorems, if two chords are congruent, their arcs are also congruent. If the radius or diameter is perpendicular, then it bisects the chord or the arcs. And if you have two chords that are the same distance away from the center, the chords are equal to each other. So we'll start with this example. Trapezoid. ABCD is inscribed in circle O. If AB is congruent to BC, which is congruent to CD, and the measure of arc BC is 50, what's the measure of arc APD? So let's label what we know.
BC.
So AB, BC, and CD are all congruent. So we can mark those three as being equal. And measure of arc BC is 50. So what else is 50? AB and CD. We want to find what the measure of arc APB is. So A, P, D. How are we going to find that measure? Well, we'll add the 350s together, definitely. So A to D here, that arc is 150. So what would be the remaining? Not from 180, from 360. Yeah, then we just subtract from 360. So measure of arc APD is 210 degrees. Is that okay? All right, let's look at another example then.
That's all we have to do for that one?
Yep.
Oh.
In circle P, CD is 24, PR is congruent to PQ, the measure of arc CY is 45, find the following measures. So we want to find AQ, RC, measure of arc DY, and measure of arc AB. So let's first start marking what we know. So we know PR and PQ are congruent. If PR and PQ are congruent, so what can you tell me about chord AB and chord CD?
They're both 24.
They're both 24. Why are they both 24? They're congruent because they're the same distance away. So CD would have to equal AB because they're the same distance away. So that means CD is 24, so AB is also 24. Okay, so the whole AB here is 24. Now there's also this perpendicular sign. So perpendicular sign, what does that make this chord? Yep, AQ and BQ are equal to each other. So from A to B is 24. What's from A to Q? 12.
A to Q is 12.
Yep,
Because it's half of 24.
because it's half of 24, right? So what would RC be? 12. Good. Okay, So now we have arc CY, we're told, is 45 degrees. We want to know what arc DY is. Why is it congruent? Yep, because it's perpendicular, so DY is 45 degrees. And then we want to know what arc AB is.
90.
90. Why would it be 90? Yep, they're both 45. They're congruent to each other. Add 45 and 45 up, we get 90. Is that okay? Yes?
Is this going on for recording? Like,
No, but not everybody's here today.
is this assignment?
Together.
The radius of circle O is 32. PQ is congruent to RS. PQ is 56. Find the following measures: PB, BQ, OB, and RS.
28. RS is 56. We know that already.
Okay, so PQ is 56, so you're saying RS is 56 as well. Why is RS also 56? Yep, because it tells us right here that they're congruent to each other, so RS is 56. So what would PB have to be?
28.
Why is PB 28? Yeah, half of 56 because we have that 90 degree right here, so these two are congruent to each other. So half of 56 is 28.
Same with BQ.
BQ then would also have to be 28.
Would OB be 16? Because we do 32 divided by 2.
No, OB is not 16. What is 32 though? 32 is what, the radius? Do we have a radius drawn anywhere?
No.
So I'm going to draw a radius so that I can find OB.
Oh, so then P.
Don't we plug it into that problem we used to?
Nope.
It's 28.
What would P to OB?
Pythagorean theorem.
Yeah, PO here would be what?
32.
32 because it's a radius, and we know that this is 28. Is this a right triangle?
Yeah.
So the Pythagorean theorem. So you'd go, okay, well 32 squared would have to be 28 squared plus b squared.
Wait, how do you know it's 32 though?
Because we're told that the radius of circle O is 32. So anytime I go from
Oh, okay.
the center to an outside point, it's going to be 32. So I can just make it go to P to form a right triangle.
How do you know A, B, and C? Or can you just guess it?
C is always a hypotenuse in the Pythagorean theorem, which has to be 32. And it doesn't matter what you use for A and what you use for B. So what's 32 squared?
784.
784. 28 squared?
1024.
No?
1000.
No, that would be
Oh.
That
right.
one makes sense.
No. 28 squared is 784.
Okay.
32 squared is 1000.
So 28 squared is 784,
Yes.
and 32 squared is 1024.
24.
That makes more sense.
So how do we get b squared alone?
Yeah, it's minus 780.
Minus the 784. So 1024 minus 784.
240.
240 is b squared, and then how do you get b?
Both sides of them.
Square root. So square root of 240 is about what?
15.
15.0?
No, 15.5.
5. What was the width of 14 then?
I accidentally said it wrong.
Oh, okay. 15.9.
5.
0.5. 15.5.
I said 5.
You did say 5. I said 9. My fault. Is that okay?
I'm still blaming.
Now, the key here is if you are looking for, like this little segment here, OB, or you're looking for the radius, you have to make right triangles here. That's going to happen for quite a few of these.
You want our assignment from yesterday?
I already collected the assignment from yesterday. I don't know where you were, not paying attention, too excited about the birthday sticker,
I guess.
any or all of the above. So your assignment due on Tuesday is page 540, 11 through 33, 54 to 59.
Don't turn it off.
There's I'm just